Woohoo! This is Math 60, Intermediate Algebra, and this is the Chapter 4 practice test. And before we get started, I wanted to just go over the difference between a practice test and an actual test. Both tests will be online. For the practice test, I have written up all the problems, and there's a PDF that you can download and print out if you'd like. Or, just like in the regular test, just make sure you have some paper, whatever paper makes you happiest. Quadrille makes me happiest. Ooh, look at that. Look at those beautiful little squares. And have that available along with pens, highlighters, in my case, a lot of correction tape. And, even red pens if you want to hold the pen of destiny in your hand. And then make sure you're writing down the problems, because none of these problems are problems you can do in your head. Maybe the first one, but it's a little tricksy. Also, the difference between the practice test and the actual test are on this lovely piece of paper. The practice test, is there a time limit? No, you can take as long as you want. Are there retakes? Yes, you can take it as many times as you want. Can you use your book or your notes or your friend or your cat? Cats don't generally help. And I got to warn you, if your cat does give you an answer, there's a good chance that he's giving you the wrong answer because, cats. So, practice test, there are no rules here. Go bonkers, do whatever you like. Actual test, you get 90 minutes. Now, the good news is this particular chapter 4, the problems go pretty quickly. They're not long, forever problems, and there are no word problems. Woohoo, no word problems. Can you retake it though? No. Once you start it, that's it. That's your test. The test will go for 90 minutes unless you submit it earlier, and then it'll just turn off. Are you allowed to use your book, notes, friend, or cat? No. This is a cat-free test. So I am depending on your honor as students and as citizens of the world and the universe to not use other resources when you're taking the test. The goal of the test is to see, did you understand the material I presented, or did all of my silly puppets get in the way of understanding? So go ahead and grab your favorite support staff. I've got my Sharktopus and my Godzilla, and let's get started. Woohoo, inequalities. Woohoo, okay. So the way I have formatted this is I've got the problem very close to the way it's actually written, and then I've got the possible answers. Now, Canvas changes the order of the answers, so you will not see them in exactly this order because it switches around for everybody. So this happens to be the order that I saw when I looked at it, so I could copy it down onto this. Okay, so I've got an equation, an inequality. Negative 7y plus 3 is greater than negative 2y minus 12. Okay, so you've got some choices to make. One choice is, where do you put the variable? And the answer is anywhere you want. You want to put it on the left? Awesome. You want to put it on the right? Awesome. There are trade-offs to each. Since many or most people would want to put it on the left, spoiler, I'd actually want to put it on the right personally, but because I know a lot of students want to put it on the left, I'll go ahead and put it on the left. So I'm going to add 2y to both sides. Could I add 7y to both sides? Absolutely. Could I add 100y to both sides? Yes, but it would not help. Okay, so over here, I've got negative 5y plus 3, and then I've got just the negative 12 because remember that the negative 2y and the plus 2y, just like in an equation, cancel each other out. So we've effectively, quote unquote, moved the variable. Woohoo! Sorry, I'm fighting with a rabbit under my desk. I'm not really fighting. He's winning by default. He's got big teeth, they're a little bitey today. Okay, we got negative 3, negative 3. He's trying to sleep and I'm being too loud. So let's see, over here on the left, I've got negative 5y is greater than negative 15. Note that adding or subtracting from both sides does not change the inequality. Woohoo. Okay, so I've got this, and now I'm going to actually have to get myself to an isolated variable. The only way to do this is to divide both sides by a -5. Now, if you divide by a negative, let me move this up so we can see it. Sorry, guys. If you divide by a negative, you have to flip the inequality. So flip the inequality when multiplying or dividing by a negative. So I'm going to go ahead and make a big yellow box here. Obviously, you don't need to do this in your notes, so you probably are already done with this problem. I will catch up soon. Notice that I'm going to flip the inequality around because I'm dividing both sides by -5. And then over here, I get y is less than -15 over -5 is 3. So on my graph, if I were to graph it, if here's 0 and here's 3, I'd be marking, can you see that? Yep. I'd be marking this part of the graph like that, with a parenthesis or with an open circle. So the original problem, and the different problems will go back and forth, whether it wants an inequality or whether it wants an interval. Unfortunately, graphs are really hard to do in this setting, so you won't see any graphs in Canvas, at least right now. It's possible that if you're watching this in the future, I will have made a new video because I was able to do graphs, and then you wouldn't be seeing this either, so never mind. Okay, so I'm looking for an interval. Okay, so when I go down to my answer, and I really do recommend this, figure out what your answer is first, even though it's multiple choice, because once you see all the possibilities, once I see all the possibilities, my brain scrambles. So what I always do is answer it completely. So I'm going to go from -infinity to 3, and then I will go ahead and go up here and see which one matches that. So let's see, can I get this in the screen so you can see both? Yes, there we go. -infinity to 3, is right there. So again, I encourage you, get your own answer before you go looking at the options, because some of these options personally would make me doubt myself. Okay, so 1 down, woo! Fun times. Now let's do number 2. Solve this inequality. Spoiler, they're all inequalities. Solve this inequality and give your answer as an inequality. Okay, so this one, and I know I lied before because I said never look at the answers, but I'm just going to show you. See how these are in inequality formats? We know we're going for inequalities. 8/9 x plus 5/3 times the quantity x minus 6 is less than or equal to x. Now, this problem in particular, this is more difficult. And something to keep in mind is the way I've written this test is each problem is worth 10 points, even though the first one was much easier than this one. So definitely in this test, do the problems that are easiest first to get those points, and then come back and focus on the harder ones. This one is going to be contentious because I can right off the bat see 4 or 5 different ways to solve this. I'm going to follow the techniques that I suggested in class, which doesn't mean you have to, but that's the way I'm going to do it. And I'm going to go ahead and look for an LCD and clear fractions. So I've got 8/9 and 5/3. Those are my 2 denominators. So I've got a 9 and a 3. And here's the thing. A lot of people would say, oh, the LCD is 27, and that's fine. If you use 27, you're going to have a bit of a mess to clean up, but it will work out just fine. You could even use 3,000 if you want. No, you couldn't. 9,000. There we go. You could use 9,000 if you wanted to. It would be a big mess, but you could clean it up. But if you notice that 3 and 9 overlap, the LCD 9 would actually work for both 3 and 9 because they have so much in common. So let's clear fractions. Woohoo! So I'm going to write, and again, it's going to go a lot faster for you, I would guess, because I'm going to be writing out all of these to make it look good in the scans. Feel free to run ahead. There. Okay, so let's take a look. I've got one. This is one big term. This is one term, two terms, three terms. So I've got 3 9s. Notice I use 9 over 1 where I've got a fraction. I use 9 where I don't have a fraction. And I have a brand new puppet that goes with my puppet. So my puppet has a puppet. Let me see if I can get this together. Stomp, 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 stomp. Stomp out fractions with the LCD. Least common denominator to the rescue. Okay, now, as usual, I'm going to rewrite this. You do not have to. Again, I'm trying to be thoughtful about the fact that some people don't watch the video and they're just looking at the notes. And so I'm trying to keep it from being too hard to read. The 9's going to cancel with the 9. The 3 is going to cancel with the 9. And so I've got 1 times 8x plus 3 times 5 x minus 6 is less than or equal to 9x. This is great. I have stomped out all the fractions. Stomp, stomp, stomp. And then I get 8x plus, now I have to do this multiplication here first because we're going to distribute it. So these two things I have to multiply. And I know everybody's looking at me going, wait a minute, this is not order of operations. No, order of operations, order of operations is complicated at this point. What I would say is since 3 and 5 are both outside, they have to go distributing through. Combine them, distribute all together. So I get 15x minus 15 times 6, which is 90. I can pretend that I knew that off the top of my head, or you could realize that I've worked this out already, before I made the video, so I remember it. I'm going to combine like terms on the left and get 23x minus 90 is less than or equal to 9x. And then, as I said, make sure you've got a nice supply of extra paper. I've got 23x minus 90 is less than or equal to 9x. Woohoo. Okay, so now I have to figure out where the x's are going to go. I'm going to bring the x's over to the left. And I'm going to use this opportunity to show you what happens. Now, a lot of people get stuck at this point. On the left side, they're like, okay, 23x minus 9x is 14x minus 90. And then they're like, oh no, this is all gone, so it's done. And the answer is no. I've got a less than or equal to, and 9x minus 9x is not nothing, it's 0. Now, if you are an ancient Roman, you'd have to stop at that point. But for the rest of us, and there are a lot of other civilizations. Rome is famous. They didn't incorporate 0 into their number system, and actually were a very successful culture, but we have 0, so we don't have to stop there. The trade-off is they had to know Latin. So, zeros, having to keep going with math versus Latin, that's the trade-off. They also did not have alarms. Okay, so next up, I'm going to add 90 to both sides. Dun, dun, dun. I don't know why we need music today. I feel like we should have music. I should have music, but I don't know how I would choose music that everyone would like. And my last step is to divide by 14. Notice that when I'm dividing by a positive number, I don't have to change the inequality. So in some ways, this problem is a lot easier than the previous one because everything is very straightforward, with the exception of this kind of mess to stomp out all those fractions. Oh my gosh, fractions, am I right? Just always in your day trying to ruin it. Okay, now, generally speaking, unless I've made a mistake, you always want to reduce. So let's see, I've got 90 and 14. I have no idea. My guess is that 2 is going to go into both of them. 2 into 14 is 7. 2 into 90 is 45. And then I think about it and I realize 45 and 7 have nothing in common. So I believe this is my answer. So let's go to the possibilities. Okay, x is less than or equal to 45 over 7. Now, sneaky. I don't know if you guys can see that, but this says 0 is less than or equal to x is less than or equal to 45 over 7. And this one simply says x is less than or equal to 45 over 7. So these seem like they're the same. They are not. Was this a double inequality? No. Was this a compound inequality? No. Is there any reason to include a second inequality with a 0? No, that is just a red herring. The answer is x is less than or equal to 45/7. That's right there. Do not fall for my tricks. My evil math teacher tricks. Do not fall for them. Wahahaha. Say, not today, math teacher. Okay. That's exactly what my papers are saying, too. Okay, number 3. We are almost halfway through this test. Woohoo! So, this problem, solve this inequality and express your answer as an interval. And again, this is an interval problem. So my answer, I'll have to go to the extra step of writing the interval. This seems pretty simple. It is a little misleading, so let me walk you through this. I'll remind you that when you're given this kind of a compound or double inequality, you want to make sure that the variable stays in the middle. So I want to isolate this. And so I want to remove that 5. So I'm going to subtract 5. And remember that if there are two inequalities, there are two inequality signs, I'm going to have 3 parts. So I'm going to subtract 5 there, and I'm going to subtract 5 there. So I'm going to subtract 5 3 times. I'm going to call it 3 sides. That's what we call it with equations. So let's call it that with an inequality. So I get -7 is less than the opposite of x is less than 2. Now, if you stop there, you are going to miss the opposite sign. But notice how sneaky I am. From -7 to 2, I gave you that option. So be vigilant. Do not fall for my tricks. So what do we do now? Well, there's a minus sign right there. I got to worry about that minus sign right here. Let's see. How do I? Blue might be too dark. How about green? Green might be too dark. So what I'm going to do is I'm going to divide everybody. So remember, there are 3 sides. I'm going to divide everybody by -1. Now, if you divide everybody by -1, what happens? Each of the inequalities switch around. They switch around in situ. They switch around right where they are. They don't have to switch places completely. So this one switches there and this one switches there. Why does it make a difference? Well, if one of them has an equals attached and the other does not, you got to make sure that they stay parallel. Okay, so then I've got -7 over -1, that's 7, is greater than x, which is greater than -2. Now, here's the thing. Our number system isn't set up to have the big number on the left, just because probably, I'm going to guess it's the Greeks, the ancient Greeks, possibly also Greeks right now, because, you know, they're still around. And then the Romans, and then the English and the Germans and the French, we're all reading from left to right. So because of that, we're doing this algebra from left to right. And so the big number being on the left and the little number being on the right is problematic because our number line goes the other way around. So I'm going to have to take this and flip it around. Now, in a perfect world, I could just take this piece of paper and turn it over, and you could see that the -2 is on this side and the 7 is on the right. If you can see that, I don't know if the video is showing it to you. So it goes from -2 is less than x is less than 7, but it's hard to read the numbers, of course. So that's what we're going to do. I'm going to take this inequality and write it from -2 to x to 7. And then I make sure that the little end of this inequality is towards the -2, and the little end, the pointy end, is pointing towards the x. See how I did that? So this is different. We did two different things. When we divide by a negative, you actually flip the inequality. If the inequality is written in a way that we can't write as a graph, we take it and we switch it. Now, do you have to switch it? It's considered polite, but you'll notice that these answers are intervals. So if you're able to look at this and figure out what the interval is, there's no reason to switch it around. It's just how well can you read things that are written backwards. Sometimes people write English backwards, and some people can read it and some people can't. So this is math written effectively backwards. So I'm going to start with -2. This is a strict less than, and go all the way to 7, strict less than. So I'm going to start with -2, end at 7. And let's see, do I see this option up there? Woohoo, right there. And we are halfway done with this. Woohoo. You may be premature for a dance party. Okay. Now, I will warn you that although they are not long problems, the last two are Trixie problems. So I just walked through chapter 4 to write these out. And so you'll see that these are coming towards the end of the chapter, which are, the more advanced, fun, exciting, thrilling problems. So solve this inequality and express your answer as an inequality. Okay, so we don't have to convert to an interval. What we're going to do is just go to an inequality. So this is an and problem. So I've got two inequalities. I need to convert them together. So remember, this is one of those ones I'm going to look at the overlap. So 5x minus 5 is greater than 5. Okay, so let's see, plus 5 plus 5. 5x is greater than 10. And then I'm going to divide. Notice that there's really no shenanigans here. This is a very straightforward inequality. I made each of the individual inequalities not so shenanigan-y, because what we're going to have to do with the two of them is a lot more complicated. So this part should be fairly straightforward if you made it through the first problem. And then the second equation, or inequality, x plus 4 is less than or equal to 7. Ooh, that's exciting. Again, yay. I love my little tape runner. I'm going to subtract 4 from both sides. And then I get x is less than or equal to 3. Remember, when I'm subtracting, the inequality doesn't change. Only multiplication and division by a negative. Okay, so I've got two inequalities. So I had the blue inequality right here. I should have boxed these before I did all this work, and then the yellow inequality. Woohoo. So I've got the two inequalities and I want an and. So this is, remember, if I say and, this is an intersection or the overlap. So remember, there was the intersection, this guy, which means you just look at what they have in common. And then there's the union, which means we let everybody in. So I'm going to set these two up. There's a lot of ways to do this. You don't have to follow this method, but I'm going to say x is greater than 2. I'll set up a quick little line. And then x is less than or equal to 3. I'll set up a quick little line. I'll put 2 there and 3 there because those are the big players in this one. Now for the blue one, it's x is greater than 2. So I start at 2 with a parenthesis and try to avoid too much smeary town. There we go. And x is less than 3, or sorry, less than or equal to 3. So I'm going to start at 3 with a big old bracket, and there we go. Not too bad in smeary town. And then what I want to do is, if I had thought ahead, I would have done these on clear plastic or something, and then we overlap them. It'd be totally cool, and you'd see, oh, it's green. Wow. Yeah, I didn't think about that. So x is greater than 2 and x is less than or equal to 3. Well, that means the overlap. Now, 2 is included in the yellows, but not in the blues. So we're going to just have that parenthesis there. 3 is included in both. So I'm going to have a bracket there. And it looks like that. So now we're all like, oh man, this is annoying because, oh no, it's not in intervals, it's in inequalities. Ugh. So I have to remember, okay, so 2 is less than x is less than or equal to 3. Sorry, what do you guys think? Starts at x sits between 2 and 3, parenthesis, so no equals at 2, bracket, so equals at 3. So 2 to 3. And let's look up here. Can you see both? You can't really see both. But you're going to have to take my word for it. I want to go from 2 to 3. And notice a whole bunch of options, but I see the one we want right there. So I'm just not even going to look at the others. Woohoo. And now it's very exciting. I don't know if you guys are all excited. I'm certainly excited. One last problem. Woohoo! Number 5. And of course, it's the problem you knew was coming. It's the absolute value inequality. Dun, dun, dun. But it's not so bad. We've got the absolute value of 5x minus 4 is greater than 11. And we're looking for an interval. Remember, with greater thans or less thans, when you've got an absolute value, you're going to be setting up either 2 options or a double inequality. In this case, this is greater than 11, which means we're on the outside. We're bigger than. So the first part is always just to write the inequality without the absolute value. That's always going to be part of the answer. And in this case, because it's a greater than, we're also going to say 5x minus 4 and then is less than negative 11, right? So we're going to the outsides. Either you are bigger than 11 or you're smaller than negative 11. You're not in the middle. You're on the outsides. Okay, so very, very quickly, 5x is greater than 15. Divide both sides by 5. X is greater than 3. And then here, add 4. 5x, I'm ughing because I got negative 7. Ooh, but it's not really a problem. We're only going to have to work with it very briefly. Just at the end, it makes a negative 7/5. Don't panic. Now, again, I'm going to try, and this is an or. So this is going to be 2 pieces. So let's see. X is greater than 3. The interval for that is starting at 3, going to infinity. And x is less than negative 7/5 is starting from negative infinity, going all the way up to negative 7/5. And then we're going to have a u in the middle. But I'm going to have to switch these, right? Because usually you start with the first one. So negative infinity to negative 7/5. What do I mean the first one? Well, you start with the smaller one. You write them in order of the number line. So as if you were reading this off the number line. So that's why I switched it. Okay, so let's take a look here. The good news is there are only 2 possibilities with unions in them, right? All the others have shenanigans, so leave those out. I go from negative infinity to negative 7/5. It's right there. Not going to let the other problems worry me. And that's it. That's the practice test. Again, ask questions before you get to the actual test. Once you start the actual test, you have to finish it. And remember that on the actual test, there's one more problem, and that's the extra credit. Woohoo, extra credit, which you cannot get wrong. And then remember to ask me lots of questions, ask the tutors lots of questions, and we will get through this. Woohoo, you're awesome. Congratulations. We made it in under 30 minutes. Yay, dance party, dance party. Okay, math on, guys, math on. Dance lots. Have a good day. Remember to get some exercise, eat your vegetables, get some sleep. Don't stress so much. Laugh a bit. Stomp out the fractions with the LCD. Woohoo.